Statement 1 tells me that n squared is an integer, like 3 or 4. If I square something and I end up with 3, that means I must have started with the square root of 3. So if n squared is 3, then n is the square root of 3. And likewise, if n squared is 4, then n is 2. Is n an integer? For the square root of 3, no. That's about 1.7. Is 2 an integer? Yes, it is. So I end up with two different answers here, meaning statement 1 is not sufficient to tell me whether the answer is yes or no. So I can cross off A and D. Now let's look at statement 2, which says that the square root of n is an integer, like 1, 2, 3, 4, 5, etc. If the square root of n is 1, that means n is 1. If the square root of something is 2, that means the something itself is 4. And so on and so forth, 9, 16, and 25. Is n an integer? Yes, 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 yes. Always and for every s, because it's always going to be a perfect square, all of which are integers. So statement 2 is sufficient to answer that question. The answer is yes, and so B is the answer.